So you've probably heard that scientists have literally found thousands of planets orbiting around other stars, so-called extrasolar planets, usually abbreviated as exoplanets. Well, we've only known about the existence of these other planets for about 20 years. At the start of my career, I would say that we know of no planets outside the solar system. Now we're practically tripping over them. What's happened? Well, obviously improved technology. We've developed a number of different techniques that employ different technologies that allow us to find these thousands of exoplanets. Now, obviously the most obvious, if you will, but actually the hardest to do is if you just look at a star and go, yep, I see a planet orbiting around it. Now, the problem is that stars are incredibly bright and planets are incredibly small and dim. But we can use special techniques to literally block out the light from the star, and that allows us to see the little planet over here. So direct imaging is one way that we can actually get a discovery of an exoplanet. Another way that we can do it is to use the general theory of relativity, the warping of space-time. And light is bent by gravity. So what happens is, if you actually have a star, imagine this is a star, going in front of another star, imagine that's my nose, what actually happens due to general relativity is that the light from my nose has to bend around this finger, which means that that light from both sides of my nose is actually bent, and the star in the front will actually look brighter as it lines up exactly with my nose. I know, counterintuitive, you'd think that it would be dimmer. But due to the bending of light, due to general relativity, the light from my nose bending around both sides of my finger will actually add to the light of my finger, but only when they're directly in front of each other. So, how does that find a planet? Well, imagine that this star has a little planet, okay? So, as the star lines up with my nose, you see a brightness of light. But then, as my pinky, as the planet lines up with my nose, you'll get another little blip. Planet found. That's called microlensing. Another way that you can find exoplanets is something called astrometry, or what I call the drunken star. What happens is that you will see a star looking like it's wobbling as it goes through space, like your drunk star, go home. Okay? What's actually happening, of course, is that the star is wobbling because the gravity of something else next to it is pulling on it, just a little teeny tiny bit. It's not wobbling nearly as much as my finger is showing you. So if we see a star that looks like it's just slightly wobbling, we can tell there's something orbiting around it. And due to Kepler's laws, we can figure out the mass of the thing that's orbiting around it, and if the mass is small enough, we have a planet. That's kind of a difficult way. We haven't found too many planets that way. A much better way is by using the shift in the light, the Doppler shift, because as that star wobbles, its light is going to be slightly blue shifted or red shifted. So as the star wobbles towards you, the light will be slightly blue shifted. As the star wobbles away, it'll be slightly red shifted. And we're going to see this pattern. Blue shift, red shift, blue shift, red shift, blue shift, red shift. And the amount, again, of that shift in the light gives us the amount of wobble in the star, which gives us the mass of the planet going around it. That's been a really great way of finding exoplanets. But by far, the most productive way today of finding exoplanets is something called the transit method. And that takes into account the fact that under the right conditions, the planet can go right in front of the star and block out a tiny little bit of light. And I discussed that more in the video about the Kepler Space Telescope.